In this video of the Advanced Algebra Final Exam Review for the fall, I am going over numbers 18 to 29 in this video. So like here, looking back at our graph of our parabola here. Now notice the solutions, right? The solutions were always the x-intercept. So the solutions are -3 and 2. So then the vertex is always that minimum or maximum point. So here, so at about, I would say 0, -0.5, close to -6 here. So -0.5, we're just estimating -6 is the vertex. So then here, the y-intercept, and well, that was probably just below it too. So maybe about like -6.2. But again, estimating the vertex. So then the y-intercept, where the graph is crossing the y-axis, is here at -6 or 0, -6. And then over the interval 0 to 2, right? That's your x values. So from 0 to 2, we're looking at this portion of the graph. Notice those values, read it left to right, are increasing and below in the negative. So those values for f of x are negative. Then our end behavior, as we're going to the right, as x's are approaching infinity, our graph is going up. The end, f of x values are approaching infinity. So number 19, which statement is false about this situation in regards to revenue R? So here, the maximum possible ticket price is $15. Well, no, because we could go to $30. So here, the maximum is not A. The possible revenue is $1,125. Or, oh, well, hold on. So we're looking for false. So let's see if, sorry, I just realized that. Let's see if A is our answer and everything else is true. So the maximum possible revenue. So the max is here halfway at 1,125. So this is true. When tickets cost $10, the revenue is $1,000. So again, true. At $20, the revenue is also $1,000. So that's why the answer is A. Then in number 20, going back to our simplifying, remember here, when dividing top to bottom, subtract the exponents. Now keep in mind for the base of 3, that is an exponent of 1. So this is 1 minus 5/3. So then for the base of 7, starting up top, right? So 4/9 minus -1/9. So now notice here, you have 3 to the -2/3, and that's why here you have 7 to the 5/9, because notice two negatives adding together make a positive. But because of the negative exponent, that's why this is in the denominator, and the answer is C. So then 21. Notice how here inside of the fifth root, you're multiplying, so add the exponents. Bases are the same. So this is y to the -2. So now if I want to rewrite, this is y to the -2, then over 5, right? Because this is inside of the fifth radical. Because of the negative exponent, that's why the answer is B. So now focusing on solving our equations here. So here, for example, with this special case, notice how first we need to get this by itself and divide by 2. So now you've got x plus 4 squared is equal to 3. So now take the square root, right? Because this is all inside parentheses together, so we got to get rid of the exponent. Take the square root. So this is x plus 4 is equal to plus or minus radical 3, because you can't take the square root of 3. That's why here, when you do the last step and subtract 4, that's why the answer is B. Now here, you could do bottoms up. So solving our quadratic. So this is x squared minus 13x plus 36 is equal to 0. Then factor. So what numbers multiply to get 36 and add to get -13? -9, -4, right? Two negatives make a positive when multiplying, add to get the negative. But whatever you multiply by in bottoms up, divide by 2. So this is 2x minus 9 from bringing the bottom up, and x minus 2. But again, solving, change those signs. So x is equal to a positive 2, and positive, here's your fraction, 9 over 2. That's why the answer is A. Now you could also graph this in Desmos, right? Because remember, where the graph crosses, right, then that's your solutions, the x-intercepts. So if you were to graph this in Desmos, here it is. We can zoom out. So here you go. You can see it's crossing here at 2 and 4.5. And 9 divided by 2 is 4.5. So then question 24. Again, you got to get the radical here by itself. So subtract 2 from both sides. So now I've got the square root of 7x is equal to 14. Now don't divide by 7 because it's inside of the radical. So that's why you need to square both sides first. Get rid of the radical. Now I've got 7x is equal to 196. Now divide by 7 and x is equal to 28. So now 25. Here again, you can solve this exponential algebraically or graph this in Desmos. So how about this? We could show how this would look in Desmos, right? So here, make sure that you would graph the left side, so 8 to the 2x, but see how you have the 24 here? You would then have to make sure to put not just 24, but y is equal to 24. So when you graph these in Desmos, notice, right, that's 8 to the 2x, and y is equal to 24. So notice here, we do have a solution, and the graphs are crossing here at about 0.674, or 0.764. So let's see if we get that answer algebraically. So again, the exponent is by itself, so you write it as a log. So this is log base 8 of 24 is equal to 2x, your exponent. Because now notice, here you have change of base. So log of 24 divided by log 8. So now here you get about 1.528. That is equal to 2x. Divide by 2, and x is approximately 0.764. So notice how here it matches with our graph. So now in 26, notice how you have exponents on both sides, but the bases are different. We need them to be the same. So we can bring down 5 to the 2x plus 4, but then rewrite 125 as a base of 5. 5 to the third power is 125. But then don't forget to bring down 15 minus 3x. So now that the bases are the same, they cancel out. Bring down 2x plus 4, which is equal to 45 minus 9x from distributing 3 here. So now notice I'm going to solve for x and see how this is a negative. So let's add 9x here to both sides. So now here you get 11x plus 4 is equal to 45. Now you can solve your two-step. So subtract 4, so 11x is now equal to 41. Then divide, and you're left with your fraction 41 over 11, or you can also get a decimal here as well. So now 27, we're solving a log equation. But notice how it's being multiplied by 5. So again, divide by 5, right? Get it by itself. So now I've got log of x minus 3 is equal to 2. Now it's just the one log, so we have to convert it. But what is the base? Common log base 10. So this is 10 to the second power is equal to x minus 3. Well, 10 squared is 100, and that is equal to x minus 3. So when you add 3, x is equal to 103. Notice here we have another log equation, but it's being added by 3. So first, subtract 3. So now I've got the natural log of x is equal to 3. So now how do we solve? Well, what is the inverse or opposite of the ln, natural log? E. So what we do to one side, we do to the other. So now x is approximately e to the third power, or 20.1. So now 29. Now notice the logs are on the same side. So do they cancel out? No. So we have to use our property of log and condense it into 1. So this is log base 3. Bases are the same. Now adding, so what do we do with our two logs? Multiply. So 8 times 2x is 16x. That is equal to 4. Now we can go through and solve, but rewrite first as your exponent. So a base of 3. 3 to the fourth power is equal to 16x. Well, 3 to the fourth power is 81, which is equal to 16x. Divide by 16, and that's why the answer here is A.